Section 2.1, problem 2. Section 1.2, problem 2. So you're given a list of functions, and you're asked to determine whether these are power functions, root functions, polynomials, rational, algebraic, trigonometric, exponential, or logarithmic functions. So let's go through them case by case. Take a look at part A. You have y is equal to x minus 6 over x plus 6. So in this case, if you notice, this is a ratio. So most likely it is going to be an algebraic or a rational function. Remember, a rational function is a specific type of algebraic function. So we would like to be as detailed as possible. So if it's a rational function, we're going to call it that. But if it isn't, then we can still say it's an algebraic function. So look at the top portion. Is that a polynomial, x minus 6? Yes, it is. The bottom, is x plus 6 a polynomial? Yes, it is. So that means this is a ratio of not just any two functions, but specifically it's a ratio of polynomials, which means we can say that this is a rational function. Part B. In part B, we're given y is equal to x plus x squared over the square root of x plus 1. Square root of x minus 1. Now here, it's not a ratio anymore. It does contain a ratio, but there's more to it. There's a sum, there's a square root, there's a square. So when we have things with that's partially a ratio, but you also have square roots, then we know that this can't be a rational function, but it is still an algebraic function. Because, again, the definition of an algebraic function is all you're doing is taking squares, square roots, raising things to the power, raising them to some root, and then using addition, subtraction, division, and multiplication. And in our case, those are the only operations that are being used, so therefore we can say that this is algebraic. Part C. Y is equal to 10 to the x. Now remember, the big difference between power functions and exponential functions is where is the variable. So for power functions, the variable is in the bottom. The exponential functions has the variable in the exponent. So in this case, x is of course an exponent. It's our variable. So therefore, it's not a power function, but rather is an exponential function. Part D. Here, the function is y equals x to the 10th. And there you go. Now, what's the difference? Well, x is not in the exponent anymore. It's on the bottom. The exponent instead is 10, which is a constant. So using the same argument we put forth before, this now is going to be a power function. Part E. Here, y is equal to 2 times t to the 6th plus t to the 4th minus pi. Now don't get thrown off by the pi. The pi is, again, just a constant, so it's a number. Might as well just be 1 or 2 or anything like that. So pi is just a constant, and what do we have? We have 2 times t raised to some integer power plus t raised to some integer power minus a constant. This fits the description of a polynomial. And lastly, f, y is equal to cosine theta plus sine theta. And of course, this one sort of stands out in relation to all the other ones because what does it involve? It involves cosines and sines, which are trigonometric functions. So this is a trig function.